All right, here is problem number 2, following off of the same kind of protocol we used in problem 1, same sort of process. We start by reading the problem. Our problem is number 2 here. Slingshot is used to launch a stone horizontally. That's important, horizontally. Anytime you see that, underlining it is a great idea. From the top of a 20-meter cliff, the stone lands 36 meters away. And then we have two parts. Part A, at what speed was the stone launched? And part B, what is the speed and angle of impact? So let's get started on number 2. All right, for number 2, we have our slingshot. I'm not going to draw a picture for this one. That's generally your first step. I highly advise always drawing a picture to help you kind of sort out what's going on and visualize it. But I'm going to start by just making our variable lists. This is the non-negotiable step 1, where we have x and y, and we're listing what we know in each. Always, 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 a equals 0 meters per second squared in the x direction. And this problem doesn't say we're not on Earth, so we're going to go with our assumption of negative 9.8 for y, again negative because it's down. I also know in this problem that delta x is 36 meters, how far away it lands. And then I know that the cliff is 20 meters high, which makes my delta y negative 20 meters. So pausing right here, if we start at a height of 0 and end 20 meters below that, it needs to be negative. Or looking at it another way, displacement, remember, is vector, so we have to have that negative sign. It's launched entirely horizontally. Remember, I said that was very important when I read the problem. This tells me that the initial velocity in the y direction is 0 meters per second. All right, so for part A, I want to figure out, I guess I'll do it right here, at what speed the stone was launched. That tells me I'm looking for speed, so a velocity. I already have a vi in the y direction, so I'm looking for vx. In order to do that, I'm actually going to need a time. And I know that I need a time because I tried to solve it and found that I was missing a time. So first, let's use delta y to find my time. Then remember, time can go in between the two, the Romeo and Juliet piece again. So delta y, I know my equation is going to be delta y equals VIYT plus 1/2 AT squared. My initial y velocity is 0, so I have 0 times time, which I don't know, plus 1/2 times negative 9.8 times time squared. 0 times anything is 0, so this term really goes away. So then delta y equals negative 4.9 t squared. I have another piece of information though. I actually have delta y. So let me fill in delta y, which I can see in my chart. Here is negative 20 equals negative 4.9 t squared. Solving that in my calculator gives me a t value, a time value of rounded 2.02 seconds. Now that I have the time piece, remember that goes in both columns, and communicate between the two, I'm going to plug that in to my delta x equals vi delta t, or just t, plus 1/2 at squared. I know in the x direction that a is 0, so I only have to worry about my velocity, which I don't know, and my time. Well, I do know delta x. So delta x is 36 equals my velocity, which I don't know, times 2.02 seconds. If I divide both sides by that 2.02 seconds, I get a velocity initially in the x direction of 17.82 meters per second. So that is my initial velocity in the x direction, and I can see that's what the key gives me. For part B over here, I need to figure out the speed and angle of impact. Well, I just found my x velocity, and my x velocity, remember, my vix is my vfx because there's no a, right? By definition, a is the change in velocity. Well, if a is 0, that means velocity doesn't change. So my vx is still 17.82 meters per second at the end of the problem. So what I need to find, just like in number 1, is vfy. So to do that, I'm going to use my vf equals vi plus a delta t. And I apologize, I keep going back and forth between delta t and t. Those two symbols are interchangeable. If you're curious about where this equation comes from, I talk about it in the answer to number 1, previous video. But let's solve for vfy here, so I know that initially it's 0, and then I have negative 9.8 times 2.02 seconds gives me a vfy of negative 19.796 meters per second. Again, just like in number 1, that is not my final answer. That's part of my final answer. In order to figure out my final answer, I need to look at my right triangle, which is 17.82 across and 19.796 down. And I want to figure out theta. I'm going to do that the same way. So tangent of theta is going to be opposite over adjacent, or 19.796 over 17.82. Using my calculator for the inverse trig function, that gives me a theta of 48 degrees. And then I still need to find the value of the hypotenuse. To find the hypotenuse, I do the Pythagorean theorem. And so I have the square root of 17.82 squared plus 19.796 squared. The square root of that, again, gives me a final velocity of 26.64 meters per second at 48 degrees below the horizontal. The only math I've skipped here is typing in the Pythagorean theorem and solving for that. That part should be something that you're comfortable with at this point, and if it is not, let me or Ms. McCaskey know. All right, that's number 2. Up next will be number 3.